Design patterns. Exam objectives. 11. 1. Given a scenario description with a list of issues, select the design pattern that would best solve the issues. The list of patterns you must know are Intercepting Filter Model View Controller Front Controller Service Locator Business Delegate Transfer Object Sections 18. 1 and 18. 2. 11. 2. Match design patterns with statements describing potential benefits that accrue from the use of the pattern, for any of the following patterns. Intercepting Filter Model View Controller Front Controller Service Locator Business Delegate Transfer Object Sections 18. 1 and 18. 2. Introduction. In our daily lives as designers and programmers, we are continuously developing our problem-solving skills. With each problem we encounter, we immediately start considering the different ways it can be solved, including successful solutions that we have used in the past for similar problems. Out of many possible solutions, we pick the one that best fits our application. By documenting the solution, we can reuse and share the information that we have learned about the best way to solve a specific problem. Design patterns address the recurring design problems that arise in particular design situations and propose solutions to them. Design patterns are thus successful solutions to known problems. There are various ways to implement design patterns. These implementation details are called strategies. In this chapter, we will introduce the following J2ee design patterns that are named in the exam objectives. Intercepting Filter, Model View Controller, Front Controller, Service Locator, Business Delegate, and Transfer Object. 18. 1. Design patterns. A brief history. A design pattern is an abstraction of a solution at a very high level. Many designers and architects have defined the term design pattern in various ways that suit the domain to which they apply the patterns. Further, they have divided the patterns into different categories according to their usage. Let's look at some of them before we go into the details of the J2ee patterns in the next section. 18. 1. 1. The civil engineering patterns. In the 1960s and 1970s, Christopher Alexander, professor of architecture and director of the Center for Environmental Structure, along with his colleagues, wrote a number of books describing and documenting the principles of civil engineering from a layperson's point of view. Of them, one of the most widely known books is A Pattern Language, Towns, Buildings, Constructions. It provides practical guidance on how to build houses, construct buildings and parking lots, design a good neighborhood, and so forth. The book examines how these simple designs integrate with each other to create well-planned towns and cities. As its title suggests, the book describes 253 patterns that are split into 3 broad categories: towns, buildings, and construction. 18. 1. 2. The Gang of 4 Patterns. Software designers extended the idea of design patterns to software development. Since features provided by the object-oriented languages, such as inheritance, abstraction, and encapsulation, allowed them to easily relate programming language entities to real-world entities, designers started applying those features to create common and reusable solutions to recurring problems that exhibited similar patterns. Around 1994, the now famous Gang of 4 Go-F Gamma, Richard Helm, Ralph Johnson, and John Vlasides documented 23 such software design patterns in the book Elements of Reusable Object-Oriented Software. They classified the patterns at the very top level into 3 types of categories based on their purpose: creational, structural, and behavioral, as shown in Table 18. 1. Table 18. 1. The Go-F categories of design patterns. Creational. Creational patterns deal with the ways to create instances of objects. The objective of these patterns is to abstract the instantiation process and hide the details of how objects are created or initialized. Structural. Structural patterns describe how classes and objects can be combined to form larger structures and provide new functionality. These aggregated objects can be either simple objects or composite objects themselves. Behavioral. Behavioral patterns help us define the communication and interaction between the objects of a system. The purpose of these patterns is to reduce coupling between objects. At the second level, They classified the patterns as falling into one of the two scopes, class or object. Thus, we have 6 types of patterns, as described in Table 18. 2. Table 18. 2. The GoF categories and scopes of design patterns. Creational. Creational class. Creational class patterns used inheritance as a mechanism to achieve varying class instantiation. Example, factory method creational object. Creational object patterns are more scalable and dynamic compared to the class creational patterns. Example, abstract factory singleton structural. Structural class. Structural class patterns used inheritance to provide more useful program interfaces by combining the functionality of multiple classes. Example, adapter class structural object. Structural object patterns create composite objects by aggregating individual objects to build larger structures. The composition of the structural object pattern can be changed at runtime, which gives us added flexibility over structural class patterns. Example, adapter object facade bridge composite behavioral. Behavioral class. Behavioral class patterns used inheritance to distribute behavior between classes. Example, interpreter behavioral object. Behavioral object patterns allow us to analyze the patterns of communication between interconnected objects, such as the included objects of a composite object. Example, iterator observer visitor. 18. 1. 3. The distributed design patterns. Though the GoF patterns served well in designing and developing object-oriented systems in both distributed and non-distributed environments, they were not created with the distributed nature of large-scale enterprise systems in mind. As the demands for more distributed enterprise applications grew, the architects felt the need to document the solutions to recurring problems as they experienced the same problem occurring over and over again. They started extending and refining the patterns over a larger scale and with a broader scope. One book that documents some 30 patterns at the architectural level is Corba Design Patterns, by Thomas J. Mowbray and Raphael C. Malveaux. Though the book focuses mainly on the Common Object Request Broker architecture Corba, the patterns described are applicable to a wide range of distributed applications, including those that do not use Corba. The authors have categorized the design patterns at 7 architectural levels: Global Enterprise System Application Macrocomponent Microcomponent Object. The authors have 2 basic arguments. The first is that software design involves making choices, such as which details of an object should be abstracted and what should be exposed, or which aspects of the objects are to be generalized and which one should be specialized. These decisions are based on the facts surrounding the problem at hand. The book terms such facts as primal forces, because they influence our choice of a particular pattern. The discussion on forces focuses on issues such as whether a pattern increases performance, whether it aids in enhanced functionality, or whether it helps to reduce complexity within modules. The author's second argument is that not all design patterns scale well at all 7 architectural levels. Each pattern has a set of applicable levels, which is an important feature that must be considered when using the pattern. 18. 1. For the J2ee patterns. With the advent of the J2ee, a whole new catalog of design patterns cropped up. Since J2ee is an architecture in itself that comprises other architectures, including servlets, Java server pages, enterprise Java beans, and so forth, it deserves its own set of patterns specifically tailored to the various types of enterprise applications that the architecture addresses. The book Core J2ee Patterns, Best Practices and Design Strategies, by Deepak Aller, John Krupe, and Dan Malks, describes the 5 tiers of the J2ee architecture: client presentation, business integration, resource. The book then explains 15 J2ee patterns that are divided among 3 of the tiers: presentation, business, and integration. The 5 tiers in J2ee. A tier is a logical partition of the components involved in the system. Each tier is loosely coupled with the adjacent tier. It is easier to understand the role of design patterns once we fully grasp the different tiers involved in a J2ee application. The J2ee architecture identifies the 5 tiers described in Table 18. 3. Table 18. 3 tiers in the J2ee architecture. Client. This tier comprises all the types of components that are clients of the enterprise application. Examples of client components are a web browser, a handheld device, or another application that accesses the services of the enterprise application remotely. Presentation. This tier interfaces with the client tier and encapsulates the presentation logic. It accepts the requests, handles authentication and authorization, manages client sessions, delegates the business processing to the business tier, and presents the clients with the desired response. The components that make up this tier are filters, servlets, Java beans, JSP pages, and other utility classes. Business. This tier is the heart of the enterprise application and implements the core business services. It is normally composed of the enterprise Java beans components that handle all the business processing rules. Integration. The job of this tier is to seamlessly integrate different types of external resources in the resource tier with the components of the business tier. The components that make up the integration tier use various mechanisms like JDBC, J2ee connector technology, or proprietary middleware to access the resource tier. Resource. This tier comprises the external resources that provide the actual data to the application. The resources can either be data stores such as relational databases and file-based databases, or systems such as applications running on mainframes, other legacy systems, modern business-to-business B2B systems, and third-party services like credit card authorization services. The J2ee Pattern Catalog. Table 18. 4 lists the 15 patterns of J2ee, with a brief description of each. Table 18. 4 J2ee Design Patterns. Presentation Tier. Decorating Filter. Intercepting Filter. An object that sits between the client and the web components. It pre-processes a request and post-processes the response. Front Controller. Front Component. An object that accepts all the requests from the client and dispatches or routes them to appropriate handlers. The front controller pattern may divide the above functionality into 2 different objects, the front controller and the dispatcher. In that case, the front controller accepts all the requests from the client and does the authentication, and the dispatcher dispatches or routes them to the appropriate handlers. View Helper. A helper object that encapsulates data access logic on behalf of the presentation components. For example, Java beans can be used as view helper patterns for JSP pages. Composite view. A view object that is made up of an aggregate of other view objects. For example, a JSP page that includes other JSP and HTML pages using the include directive or the include action is a composite view pattern. Service to worker. A kind of model view controller with the controller acting as a front controller but with one important point. Here the dispatcher, which is a part of the front controller, uses view helpers to a large extent and aids in view management. Dispatcher view. A kind of model view controller with the controller acting as a front controller but with one important point. Here the dispatcher, which is a part of the front controller, does not use view helpers and does very little work in view management. The view management is handled by the view components themselves. Business tier. Business delegate. An object that resides on the presentation tier and on behalf of other presentation tier components calls remote methods on the objects in the business tier. Transfer object. Replicate object. A serializable object for transferring data over the network. Session FADA. Session entity FADA. Distributed FADA. An object that resides in the business tier, acts as an entry point into the business tier, and manages the workflow of business service objects, such as session beans, entity beans, and data access objects. The session facade itself is usually implemented as a session bean. Aggregate entity. An object entity bean that is made up of or is an aggregate of other entity beans. Transfer object assembler. An object that resides in the business tier and creates transfer objects on the fly as and when required. Value list handler. Page-by-page iterator. Page list. an object that manages execution of queries, catching, and processing of results. Usually implemented as a session bean, serving a subset of the fetched results set to the client as and when needed. Service Locator, an object that performs the task of locating business services on behalf of other components in the tier. Usually present in the presentation tier, it is used by business delegates to look up business service objects. Integration tier. Data access object, an object that talks to the actual underlying database and provides other application components. It serves as a clean, simple, and common interface for accessing the data, and for reducing the dependency of other components on the details of using the database. Service Activator, an object that helps in processing of business methods asynchronously. Of the design patterns listed in Table 18, 5 Intercepting Filter, Front Controller, Service Locator, Business Delegate, and Transfer Object are mentioned in the exam objectives. They also cover the Model View Controller pattern, which is considered more of an architecture than a J2ee design pattern. In the rest of this chapter, we will examine these design patterns in depth. Discussing the other patterns is beyond the scope of this book, but they are frequently used as possible options in the single-choice questions of the exam. It will be helpful if you study Table 18, so that during the exam you can eliminate the incorrect choices, thereby making it easier for you to select the right answer. 18. 2 patterns for the SCWCD exam. Table 18. 5 lists the most important J2ee design patterns that you need to know for the exam. Table 18. 5 patterns required for the SCWCD exam. But before we discuss each of these, we want to describe the structure behind their documentation. The structure is called the template. 18. 2. 1. The pattern template. During the process of analyzing a problem, designing a solution, creating an action plan, and implementing the ideas, one of the most important tasks is to document each and every aspect of the process. This facilitates preserving the ideas in a systematic manner so that they can be read, understood, and reused by others. Design patterns are documented using a pattern template. The template is made up of headings. Each heading explains a different aspect of the pattern, such as the cause of the problem, the situation in which the problem can occur, and the possible facts to look for. Different organizations and pattern catalog writers use different sets of headers and, therefore, their templates vary. However, their goal is the same. Systematic documentation of the causes of the problems, the solutions provided by the patterns, their consequences and implications, examples, related patterns, and so forth. So before we start explaining the design patterns required for the exams, let's first look at the template that we have used to explain the design patterns in the following sections. We have kept the template large enough to cover different aspects under different headings, while at the same time keeping it small enough to maintain simplicity. Also, wherever possible, we have avoided long paragraphs of text and used a bulleted points approach while presenting the facts to make it easier to remember and reference. The following subsections describe the template headers. Context. This section describes the context or the situation in which the problems can occur and the given pattern that we can apply. Patterns, if not used wisely or if applied in the wrong context, can turn out to be anti-patterns. Various facts have to be sorted out, and the pros and cons of the pattern have to be evaluated against these facts before applying the pattern. Therefore, it is important to understand the situation in which the pattern may be applicable. Problem. This section provides a common, day-to-day problem that we face in the given context. Because so many developers and programmers have experienced this problem, designers have developed standard solutions for it. In many books or tutorials, you may find a separate heading called Intent to describe the intent of the pattern. The intent heading is suitable where the primary aim of the pattern is to enhance the design of the overall system rather than attacking a particular problem. In the patterns described below, we have provided a problem heading instead, and the intent of the pattern is to solve the given problem. Example. This section provides a simple example of the specified problem type. facts or forces to consider. Other than the given situation in the given type of problem, there may be various facts that need to be considered before using design patterns. These facts can vary largely from system to system, depending on the requirements. They are also referred to as forces in design pattern jargon, because they influence whether or not a design pattern is applicable in the given scenario. In some cases where more than one pattern can solve the problem, these forces can be helpful in determining the choice of using one pattern over the other. You can think of facts and forces as observations or requirements of the problem that you will take into consideration when you are evaluating the candidate design patterns for this particular situation. Solution. This section describes a typical solution that has been tried, tested, and proven by experienced developers to solve the problem, taking into account the given facts or forces. The problem-solution pair forms a design pattern. However, the solution is really a high-level design guideline that we can follow. The actual implementation of the solution may vary from context to context, and each implementation of the solution is referred to as a strategy of the solution in the J2ee jargon. Thus, each design pattern can be implemented by applying different strategies depending on the context of the problem and the facts or forces surrounding the problem. We have not provided a separate section of strategies, and we have discussed only the most common of the strategies for the patterns, since describing all the strategies is outside the scope of this book. Consequences. Implications. This section describes the advantages, after effects, and hidden problems associated with patterns. Every pattern has inherent side effects, and may solve one problem but generate another. We need to weigh the pros and cons of the pattern and find a balance between the two. Category. This section indicates which of the three categories the pattern falls into: creational, structural, or behavioral, with a brief description. Points to remember. These are the points we must take into account when considering a particular pattern as a solution. In the following discussions of the J2ee design patterns, we have provided a list of words, phrases, and terms that are related to the pattern, and which may help you to prepare for the exam. When you read a problem statement, see if you can identify any of the terms or phrases listed in this section in a statement. Another tactic is to restate the problem without changing the meaning and find any of these terms that match. This will aid you in selecting or eliminating the options in exam questions. 18. 2. The intercepting filter. Context. Client requests may have many different processing needs, and the system must be able to meet them. The system receives requests using multiple protocols, such as HTTP, FTP, or SMTP. The system must authorize or authenticate some requests, while handling others directly. The system needs to add or remove information from requests or responses before further processing. Problem. Requests and responses need to be pre- and post-processed in a simple, organized manner. Further, this processing needs to be performed without affecting the operation of the rest of the system, and must use standard interfaces in order to be added and replaced. Example. If you have to build an enterprise system that doubles as a web portal and corporate intranet, you need to ensure that different client requests are handled appropriately. Not only must a system block requests for secure resources, it must also check for trusted IP addresses. Further, it must ensure that responses and requested resources are compressed, decompressed and encrypted, decrypted as needed. Facts or forces to consider. In the context and the problem presented above, we observe that there are three characteristics of the desired system, as follows. 1. Centralized, standardized pre- and post-processing of incoming requests and outgoing responses. 2. Provide authentication, transformation, and conversion of resources as needed. 3. Perform function with minimal effect on external code processing. Solution. The solution is to separate request, response processing from the rest of the system by creating filters. These objects, more fully described in Chapter 7, provide a standardized, replicable means of altering requests and responses as needed. Consequences. Implications. The standard interfaces associated with intercepting filters allows you to stack them for multiple processing tasks. Further, this modularity allows you to test filter processing without the full system present, a centralized location for request. Response processing is important, but must not create a bottleneck. This may require distributed processing. The standard filter mechanisms allow you to dynamically insert or remove filters during application deployment. Category. Because intercepting filters reduce coupling between request processing and the rest of the application, they are considered part of the behavioral category. They function by managing the information sent from the client to the application layer, and then control the response processing. By providing a single point of contact for transforming requests and responses, they reduce the confusion associated with having many different interfaces for different client-server relationships. Points to remember. The intercepting filter design pattern consists of multiple JAVX. Servlet. Filter objects that process requests and responses in a modular fashion. These filters are described in greater technical depth in Chapter 7. Pay special attention to the following words, phrases, or terms appearing in the problem statement. Central object for processing requests and responses. Resource management, particularly regarding security, compression, and encryption standard interface allows layered processing. Intercepting filters deal with request processing, not with the application's appearance or dispatching mechanisms. 18. 2. 3. Model View Controller MVC. Context. In systems involving user interfaces, the following situation typically arises. The system has to accept data from the user, update the database, and return the data to the user at a later point in time. There are several ways in which the data can be accepted from and presented to the system users. Data fed to the system in one form should be retrievable in another form. Problem. If the system deploys a single component that interacts with a user as well as maintains the database, then a requirement to support a new type of display or view will necessitate the redesign of the component. Example. Suppose a bank provides online stock trading facilities. When the user is logged into the site, the web application allows the user to view the rates of the stocks over a period of time in various ways, such as a bar graph, a line graph, or a plain table. Here, the same data that represents the rates of the stocks is viewed in multiple ways, but is controlled by a single entity, the web application. Facts or forces to consider. In the context and the problem presented above, we observe the following facts. There are 3 tasks to be done. 1. Manage the user's interaction with the system. 2. Manage the actual data. 3. Format the data in multiple ways and present it to the user. Thus, a single component that does all the tasks can be split into 3 independent components. All 3 tasks can then be handled by different components. Solution. The solution is to separate the data presentation from the data maintenance and have a third component that coordinates the first 2. These 3 components are called the model, the view, and the controller, and they form the basis of the MVC pattern. Figure 18. 1 shows the relationship between the components of the MVC pattern. Figure 18. 1. The model view controller pattern. Here are the responsibilities of the 3 MVC components. Model. The model is responsible for keeping the data or the state of the application. It also manages the storage and retrieval of the data from the data source. It notifies all the views that are viewing its data when the data changes. View. The view contains the presentation logic. It displays the data contained in the model to the users. It also allows the user to interact with the system and notifies the controller of the user's actions. Controller. The controller manages the whole show. It instantiates the model and the view and associates the view with the model. Depending on the application requirements, it may instantiate multiple views and may associate them with the same model. It listens for the user's actions and manipulates the model as dictated by the business rules. Consequences. Implications. Separating the data representation model from the data presentation view allows multiple views for the same data. Changes can occur in both the model and view components independently of each other as long as their interfaces remain the same. This increases maintainability and extensibility of the system. Separating the application behavior controller from the data presentation view allows the controller to create an appropriate view at runtime based on the model. Separating the application behavior controller from the data representation model allows the user's requests to be mapped from the controller to specific application-level functions in the model. Category. Although MVC involves communication between the model, view, and controller components, it is not a behavioral pattern because it does not specify how the three components should communicate. The MVC pattern only specifies that the structure of a system of components be such that each individual component take up one of the three roles: model, view, or controller, and provide functionality only for its own role. As such, it is a structural pattern. In the J2ee world, MVC is thought of more as an architecture rather than a design pattern. Though it can be applied in any of the tiers, it is most suitably applied in the presentation tier. Points to remember. The model view controller design pattern, consisting of three sub-objects: model, view, and controller, is applicable in situations where the same data model is to be presented in different formats views, but is to be managed centrally by a single controlling entity controller. Pay special attention to the following words, phrases, or terms appearing in the problem statement. Separation of data presentation and data representation. Provide services to different clients. Web client, WAP client, etc. Multiple views, such as HTML or WML. Single controller. 18. 2. Forefront controller. Context. Managing an application for an individual user requires a number of considerations: controlling the application's view and navigation, performing security processing to determine which resources and services are available for the user, activating system services according to user selection, locating and accessing available resources according to user selection problem. In many cases, the functions listed above are performed in a decentralized manner. Without a single point for view management, each different view mechanism will need to access services and resources separately. This combines the system's appearance and business logic, and removes the benefits of modularity and reusability associated with MVC design. Example. In a web application that accepts credit card information, several steps must be completed. Browse the catalog. Add items to the shopping cart. Confirm the checkout. Get the name and shipping address of the receiver. Get the name and billing address and the credit card information of the payer. The different views associated with the store are decentralized. This means that they each control their navigation functions, as well as perform the tasks needed to dispatch the user's request. Facts or forces to consider. In the context and the problem presented above, we observe the following facts. Since the different pages associated with the application rely on common processing tasks, such as database accessing, they will need duplicate code. The different navigation controls may result in a combination of content and navigation. Each view must have a separate means of activating system services and locating system resources. Solution. We need a single object to manage view control, resource, service accessing, error handling, and initial request processing. This object acts as a front door to the client and is called the front controller, or front component. Among the various strategies suggested by J2ee, the two simplest ones are using a servlet or a JSP as front objects. All requests will be sent to the front controller and each request will have an action as a parameter. Consequences. Implications. The control of use cases is centralized. A change in the sequence of steps affects only the front controller component. Many web applications save the state of the client-server interaction if the user logs out in the middle of a process. When the user logs in at some other time, the previously saved state is reloaded and the process resumes from the point where it was left. In such cases, it is easier to maintain the state information using the front controller component because only one component handles the state management. Multiple front controller objects can be developed. each controller can concentrate on a different business use case. The reusability of worker components increases. Since the code that manages navigation across web pages now resides only in the front controller, it need not be repeated in worker components. Thus, multiple front controllers can reuse worker components. Category: since the front controller pattern is concerned with communication with other components, it falls in the category of behavioral pattern. In the J2ee pattern catalog, the front controller pattern is kept under the presentation tier because it directly deals with the client's requests and dispatches them to the appropriate handler or worker components. Points to remember: a front controller, or front component, is a component that provides a common point of entry for all client requests. In this way, the controller unifies and streamlines authentication and authorization, and dispatches the work to appropriate worker components, thereby facilitating use case management. Pay special attention to the following words, phrases, or terms appearing in the problem statement. Dispatch requests, manage workflow. The web application manage the sequence of steps, manage use cases. Many times, developers confuse the two design patterns, intercepting filter and front controller. Remember that while an intercepting filter performs pre-processing of requests, the front controller actually begins the main process. Further, the front controller is much more involved in controlling the application's appearance and activating system services than the intercepting filter. As an analogy, if the intercepting filter is the security guard outside a building, the front controller is the receptionist inside who can direct you to where you need to go. 18.2. Service Locator. Context. Many systems depend on distributed processing and communication. In these cases, a number of concerns must be kept in mind. The system needs to locate and access resources and services across networks. If the services or resources are unavailable, the system must create local implementations. New requests to a directory service require more time and resources than cached repetitions of previous requests. Problem: if distributed objects access the same resources across a network, their operation will cause added traffic and reduced communication efficiency. Also, each object will need updating when the network changes, a process demanding a great deal of code and time. Example: a large company contains a number of worldwide branches and needs to maintain communication throughout. Many different applications require access to similar external resources, such as personnel databases and inventory listings. In this case, the system uses Java naming and directory interface JNDI to help components find one another. But as each object accesses JNDI separately, its responsiveness slows. Facts or forces to consider. In the context and the problem presented above, we observe the following facts. Using distributed objects with external resource connections means greater code and communication traffic. Catching external requests becomes more efficient as more requests are made. Each distributed object needs to be reinformed whenever a resource changes its position in the network. Solution: the solution is to encapsulate the process of external communication into a service locator. With this method, the locator object manages all of the complexity related to locating and interfacing resources across the network. Further, to reduce the amount of time associated with making requests, they can provide request catching. Finally, if external resources have vendor-specific interfaces, this object will manage the communication complexity and make accessing the resource transparent to the user. Consequences. Implications. When a resource across the network is altered in any way, only the service locator object needs to be updated. The service locator catching makes it very efficient for multiple objects to access similar resources across a network. The service locator provides a single, uniform interface to external resources, no matter what the resource's actual API may be. This reduces the amount of code needed for distributed communication and makes it easier to test network capability. Category: because service locator objects assist with network communication by reducing the coupling between business logic and external resources, this pattern is classified into the behavioral category. By adding catching and removing sources of traffic, This object can improve the performance of a distributed application and reduce the amount of code needed to build and maintain it. In the J2ee pattern catalog, the service locator pattern is kept under the business tier because it doesn't directly deal with clients, but instead manages the connectivity of the underlying business logic. Points to remember. The service locator pattern is very simple to understand and identify on the exam, but you should pay special attention to the following words, phrases, or terms appearing in the problem statement. Provides access to heterogeneous networks and services JNDI, RMI, etc. A single point of contact for managing distributed connections and resources. Distributed request catching. Improves ease of business application development by encapsulating interface complexity. 18. 2. 6. Business Delegate. Context. In an enterprise-scale distributed application, typically the following situation arises. There are separate components to interact with the end users and to handle business logic. These separate components reside in different subsystems, separated by a network. The components that handle the business logic act as server components because they provide business services to the clients by exposing the business service API to the clients. The client components that use this API often reside in a remote system separated by a network. There is more than one client using the API. There is more than one server component providing similar services, but with minor differences in the API. Problem. Business services implemented by the business tier components are accessed directly by the presentation tier components through the exposed API of the services. However, the interfaces of such services keep changing as the requirements evolve. This affects all the components on the presentation tier. Furthermore, all the client-side components have to be aware of the location details of the business services. That is, each component has to use the JNDI lookup service to locate the required remote interfaces. Example. In the case of the J2ee architecture, the server components that expose the business service API are the session beans. The API is the remote interface implemented by the session beans, and the client components that use these services are servlets and the Java beans used in JSP pages. Figure 18. 2 shows this relationship. Figure 18. 2 relationship of J2ee components in multiple tiers. Let's look at a real-world example. A company is building a web-based application with JSP pages and servlets that need to access a set of business services. The management has decided not to develop the business services in-house, since they are readily available as off-the-shelf software from various vendors. In addition, the budget for the project is currently tight, so management has decided that they will purchase one of the more economical off-the-shelf solutions initially, and then when the money becomes available in a year, they will replace it with a more elaborate and expensive software solution. Fact or forces to consider. The presentation tier components, which in this case are the web components servlets, JSP pages, and Java beans, perform 2 main tasks. Handling the end user, which involves managing the web application logic, presenting the data, and so forth, accessing the business services. The code that handles the end user should not be dependent on the code that accesses the business services. Multiple presentation tier components can call the same set of remote methods in the same sequence. It is expected that the business service APIs will change as business requirements evolve. Solution. Create a business delegate to handle all of the code that accesses the business services in the selected vendor software. When the vendor changes, the only changes that need to be made to the company's application software are changes to the business delegate to access the business services in the new vendor software. The JSP pages and servlets will not have to be modified, as shown in Figure 18. 3. We need to separate the code that accesses the remote service from the code that handles the presentation. Figure 18. 3. The business delegate pattern. We can put the service access code in a separate object. This separate object is called the business delegate object. The business delegate object abstracts the business services API and provides a standard interface to all the client components. It hides the underlying implementation details, such as the lookup mechanism and the API of the business services. This reduces the coupling between the client and the business services. The responsibilities of the components participating in this pattern are: client components. The client components, which are JSP pages and servlets in the presentation tier, delegate the work of locating the business service providers and the work of invoking the business service API methods to the business delegate objects. Business delegate. The business delegate acts as a representative of the client components. It knows how to look up and access the business services. It invokes the appropriate business services methods in the required order. If the API of the business service component changes, only the business delegate needs to be modified, without affecting the client components. Business service. A business service component implements the actual business logic. Some examples of business service components are a stateless session EJB, an entity EJB, a CORBA object, or an RPC server. Consequences. Implications. Repetition of code is avoided. Each component does not have to include the code that will perform the lookup operation on the remote interfaces and invoke the methods. The server business logic API is hidden from the client components. Thus, it reduces the number of changes required in the client components when there is a change in the API of the server components. The business delegate can do all the business service-specific tasks, such as catching exceptions raised by the business services. For instance, it can catch remote exceptions and wrap them into application exceptions that are more user-friendly. The results of remote invocations may be cached. This significantly improves performance, because it eliminates repetitive and potentially costly remote calls. The cached results may be used by multiple client components, again reducing code repetition and increasing performance. It is worth mentioning here that the business delegate can either locate the business services itself or use another pattern, called the service locator pattern, to help locate the business service. In the instances when it uses the service locator pattern, the business delegate will deal only with the business service API invocation regardless of where the services are located, while the service locator does the job of locating the required named services. It is important to know that multiple business delegate objects can share a common service locator. Category. Since the business delegate pattern is concerned with the communication between two components, the presentation tier and business tier components, it falls into the category of a behavioral pattern. It describes how we can reduce the coupling between the two communicating parties by introducing the delegation layer in between, and how we can increase the flexibility of the design. In the J2ee pattern catalog, the business delegate pattern is kept under the business tier category since it is more closely related to the business tier components. However, note that the objects that implement the business delegate pattern reside in the presentation tier. Points to remember. A business delegate is an object that resides on the client side and communicates with the business service components residing on the server side. The client-side components can delegate the work of accessing the business services exposed by the business service components. To the business delegate, pay special attention to the following words, phrases, or terms appearing in the problem statement. Reduce coupling between presentation and business tiers. Proxy for the client. Client-side facade. Cache business service references for presentation tier components. Cache business service results for presentation tier components. Encapsulate business service lookup. Encapsulate business service access. Decouple clients from business service API. 18.2. 7 Transfer object. Context. In distributed applications, the following situation typically arises. The client-side and the server-side components reside at remote locations and communicate over the network. The server handles the database. The server provides getter methods to the client so that the clients can call those getter methods one by one to retrieve database values. The server provides setter methods to the client so that the clients can call those setter methods one by one to update database values. Problem. Every call between the client and the server is a remote method call with substantial network overhead. If the client application calls the individual getter and setter methods that retrieve or update single attribute values, it will require as many remote calls as there are attributes. These individual calls generate a lot of network traffic and degrade the system performance. Example: in the J2ee architecture, the business tier accesses the database directly or via the resource tier, and wraps the data access mechanism inside a set of entity beans and session beans. These entity and session beans expose the data via remote interfaces. The servlets and JSP pages in the presentation tier that need to access business data can do so by calling methods on the remote interfaces implemented by the beans. As a specific example, suppose we maintain the address information in the database of the registered users of our enterprise application. In this case, the address information, which is a summation of 4 other pieces of data: street, city, state, and zip, is a business entity. The access to this information is encapsulated by the application's business tier with the help of a session bean called address session bean. Address session bean exposes methods for the remote clients, such as getState, setState, getCity, and setCity. The servlets and the JSP pages then have to call each of the methods one by one on the remote server, as shown in Figure 18. 4. Figure 18. For accessing attributes remotely, facts or forces to consider. In the context and the problem presented above, we observe the following facts. A single business object has many attributes. Most of the time, the client requires values for more than one attribute simultaneously rather than just an individual attribute. The rate of retrieving the data calling the getter methods is higher than the rate of updating the data calling the setter methods. For example, the address consists of the street, state, city, and zip. Each time the user buys a product online, we want to show the full address information for billing purposes. On the other hand, it is unlikely that the user's address changes very often. Solution: create an object to encapsulate all of the attribute values that are required by the client application. This object is called the transfer object. When the client requests the data from the server-side component gathers the data values and constructs the transfer object by setting its data values. This object is then sent to the client by value, not by reference, which means that the whole object is serialized and each of its bits is transferred over the network. The client on the other side reconstructs this object locally with all the values intact. It can then query this local instance for all the attribute values. Because the transfer object is local on the client, all of the calls to this object are local and do not incur any network overhead. The transfer object on the client serves as a proxy for the properties of the remote object. The scenario is shown in Figure 18. 5. Figure 18. 5. Accessing attributes using the value object design pattern. Now, instead of making multiple remote calls on the business object, address bean, to retrieve all the attributes, the client calls a single method, getAddress, which returns all the attributes structured in an address vol object. Consequences. Implications. The remote interfaces are simpler because the multiple methods returning single values are collapsed into one single method returning a group of multiple values. Because of the reduced number of calls across the network, the user response time improves. If the client wants to update the attribute values, it first updates the values in the local transfer object and then sends the updated transfer object to the server to persist the new values. This also happens using the pass-by-value mechanism. The transfer object can become stale, that is, if the client has acquired a transfer object for a long time, there is a possibility that the information may have been updated by another client. In the case of a mutable transfer object, requests for update from 2 or more clients can result in data conflict. Category. Since the transfer object pattern is concerned with communication between 2 other components, it falls in the category of a behavioral pattern. In the J2ee pattern catalog, the transfer object is kept under the business tier because it represents the business object on the client side. However, note that even though the object that implements the transfer object pattern is created in the business tier, it is transferred to the presentation tier and is actually used in the presentation tier. Points to remember. A transfer object is a small-sized serializable Java object that is used for carrying group data values over the network from one component residing in one tier to another component residing in another tier of a multi-tier distributed application. Its purpose is to reduce communication overhead by reducing the number of remote calls between the distributed components. Pay special attention to the following words, phrases, or terms appearing in the problem statement. Small object grouped information read-only data reduce network traffic improve response time transfer data across network tiers. 18. 3 Summary. Design patterns induce abstraction, division of labor, and reusability in software systems. Consistent use of design patterns results in scalable and maintainable systems. We briefly looked at design patterns of the J2ee architecture, classified into 3 tiers: presentation, business, and integration. Then we examined in depth the 6 design patterns that are specified by the exam objectives: intercepting filter, model view controller, front controller, service locator, business delegate, and transfer object. If you are interested in learning more about design patterns, various books and articles on patterns related to all kinds of domains are available. There are books on design patterns in compiler writing, design patterns on parallel computing, design patterns specifically for the Java programming language, and so forth. During your explorations, you may soon find yourself lost in a jungle of patterns, as you discover that some of them do the same thing but have different names, and that many of them provide similar solutions but different implementations. If you are planning to study for the Sun Certified Enterprise Architect SCEA exam in addition to becoming a Sun Certified Web Component Developer SCWCD, then we suggest you become familiar with all the J2ee patterns and the various specifications that are part of the J2ee family of architectures. As for the SCWCD, with the end of this chapter, you are now ready to answer the questions based on the important design patterns: intercepting filter, model view controller, front controller, service locator, business delegate, and transfer object. 18. 4 review questions. 1. What are the benefits of using the transfer object pattern? Select 2. The type of the actual data source can be specified at deployment time. B. The data clients are independent of the data source vendor API. C. It increases the performance of data accessing routines. D. It allows the clients to access the data source through EJBs. E. It allows resource locking in an efficient way. Answers: A and B. Explanation. This pattern is used to decouple business logic from data access logic. It hides the data access mechanism from the business object so that the data source can be changed easily and transparently to the business objects. 2. Which design pattern allows you to decouple the business logic, data representation, and data presentation? Select 1. A model view controller. B. Transfer object. C. Bimodal data access. D. Business delegate. Answer: Explanation. In the model view controller pattern, model is the data representation, view is the data presentation, and controller is the implementation of business logic. Therefore, A is the correct answer. 3. Which of the following are the benefits of using the transfer object design pattern? Select 2. It improves the response time for data access. B. It improves the efficiency of object operations. C. It reduces the network traffic. D. It reduces the coupling between the data access module and the database. Answers: A and C. Explanation. The transfer object pattern allows you to retrieve all the data elements in one remote call instead of making multiple remote calls. Therefore, it reduces the network traffic and improves the response time since the subsequent calls to the object are local. 4. Which of the following statements are correct? Select 2. The transfer object pattern ensures that the data is not stale at the time of use. B. It is wise to make the transfer object immutable if the transfer object represents read-only data. C. Applying the transfer object pattern on EJBs helps to reduce the load on enterprise beans. D. A transfer object exists only on the server side. Answers: B and C. Explanation. Answer A is wrong because just the reverse is true. For instance, This pattern is not used when the attributes of an EJB are volatile, such as stock quotes. Answer B is correct because making the transfer object immutable reinforces the idea that the transfer object is not a remote object and any changes to its state will not be reflected on a server. Answer C is correct because clients require a fewer number of remote calls to retrieve attributes. Answer D is wrong because a transfer object is created on the server and sent to the client. 4. What are the benefits of using the business delegate pattern? Select 3. It implements the business service functionality locally to improve performance. B. It shields the clients from the details of the access mechanism, such as CORBA or RMI, of the business services. C. It shields the clients from changes in the implementation of the business services. D. It provides the clients with a uniform interface to the business services. E. It reduces the number of remote calls and reduces network overhead. Answers: B, C, and D. Explanation. Answer A is wrong because a business delegate does not implement any business service itself. It calls remote methods on the business services on behalf of the presentation layer. Answer B is correct because the clients delegate the task of calling remote business service methods to the business delegate. Thus, they are shielded by the business delegate from the access mechanism of the business services. Answer C is correct because the business delegate is meant for shielding the clients from the implementation of the business services. Answer D is also correct because this is one of the goals of this pattern. Answer E is not correct because the business delegate does not reduce the number of remote calls. It calls the remote methods on behalf of the client components. 5. You are designing an application that is required to display the data to users through HTML interfaces. It also has to feed the same data to other systems through XML as well as WAP interfaces. Which design pattern would be appropriate in this situation? Select 1. Interface factory. B. Session facade. C. Transfer object. D. Model view controller. E. Factory. Answer: D. Explanation. The application requires multiple views HTML, XML, and WAP for the same data. Therefore, MVC is the correct answer. 6. You are automating a computer parts ordering business. For this purpose, your web application requires a controller component that would receive the requests and dispatch them to appropriate JSP pages. It would also coordinate the request processing among the JSP pages, thereby managing the workflow. Finally, the behavior of the controller component is to be loaded at runtime as needed. Which design pattern would be appropriate in this situation? Select 1 of front controller. B. Session facade. C. Transfer object. D. Model view controller. E. Data access object. Answer: Explanation. This is a standard situation for the front controller pattern. The front controller receives all the requests and dispatches them to the appropriate JSP pages. This is not the MVC pattern, because the question only asks about controlling the workflow. You would choose the MVC pattern if it asked about controlling and presenting the data in multiple views. 8. You are building the server side of an application and you are finalizing the interfaces that you will provide to the presentation layer. However, you have not yet finalized the access details of the business services. Which design pattern should you use to mitigate this concern? Select 1 a model view controller. B. Data access object. C. Business delegate. D. Facade. E. Transfer object. Answer: C. Explanation. You already know the services that you have to provide, but the implementation of the service access mechanism for the services has not yet been decided. The business delegate pattern gives you the flexibility to implement the access mechanism any way you want. The presentation tier components, servlets, and JSP pages can use the interface provided by the business delegate object to access the business services. Later, when the decision about access mechanism changes, only the business delegate object needs to be modified. Other components will remain unaffected. 18 Design patterns: Java server pages and design